When rovers land on Mars, they travel all the way to the red planet protected by a rigid aeroshell, or heat shield. The size of that structure limits just how much scientists and engineers can fit inside.
And if you look at all the origami that's involved in packing a rover, like we're sending to Mars right now, into that confined space, and then having it deploy in the right sequence during that timeline when you've only got a certain amount of time to do it, it's very complicated.
So Neil Cheatwood and his colleagues at NASA's Langley Research Center in Hampton, Virginia, have come up with a different idea: an inflatable heat shield.
In our case, we're using inflatable because we can get a giant heat shield into a very small package and able to open it up, and so we can carry much larger vehicles into an atmosphere.
The first flight demonstration of the concept is the Inflatable Reentry Vehicle Experiment, or IRVE, a series of inflatable rings covered by a thermal blanket. What looks like a 10-foot diameter mushroom will be packed, uninflated, into a 22-inch diameter rocket and launched 280 miles in the air. Cameras and instruments monitoring its every move, temperature, and pressure on the way back to Earth.
We will launch IRVE-3 on a sounding rocket out of Wallops Island. It will go up into space, inflate to reentry shape, and perform its reentry experiment, and it will radio the data back home. When the experiment is over, IRVE-3 will land out in the Atlantic.
IRVE-3 has been tested and retested on the ground to make sure it can withstand the heat and force of atmospheric reentry. The first line of defense against those conditions, the thermal blanket, is made up of layers of commercially available materials.
This combination includes Nextel, which is an aircraft engine insulator. We use Pyrogel, which is a pipe insulation material, and then we use Kapton-coated Kevlar. Kevlar is the same stuff that police use in bulletproof vests.
The inflatable rings are also Kevlar.
It sounds counterintuitive to folks. Oh, you're using some kind of inflated donuts to work as a spacecraft. But it's a combination of using materials that can handle the high loads and then properly inflating them.
IRVE has already had one successful test. Assuming IRVE-3 does as well, engineers hope to expand the concept, literally, and test a larger inflatable in the future.